Okay, hopefully now they can hear me online. So thank you, everybody, for. Sorry, I need to close the transcript.
This is a transcript. Wow.
Yeah. So good afternoon, everybody, those in person and those online to the external seminar. So today we have Manel Grifol from the Polytechnic University of Catalonia. But Manel has been in Dundee for almost 1.5 years, 2 years?
Yes, now it will be 2 years.
2 years, doing a sabbatical, working with Alan Cuthbertson in the fluid laboratory, fluid dynamics lab.
Lab.
So just a quick bio before I'll give the floor to Manel. So Manel did his PhD in civil engineering in Catalonia in 2009. And has been lecturing there for 7-8 years.
Something like that.
Yeah, exactly. Yeah. But in terms of research, Manel has been working with several universities across the world, from Danish institutions to the USGS, and also universities in developing countries, particularly in Mozambique, with the University Eduardo Mondlane and Machixe. And in terms of your research, Manel fundamentally works with physical processes and in coastal areas, and fundamentally related to waves, currents, and sediment transport, and also in the development of operational models for coastal and harbor management. And for that, Manel's research fundamentally involves the use of observations, remote sensing, and numerical models. And today, Manel is going to be talking to us about hydromorpho-ecological processes and interactions in highly pressured coastal bays, using as example the cases of Fangar and Alfax bays in the Ebro Delta. So I'm going to give the floor. Oh, I need to share the screen actually first. Thank you very much.
Okay.
Manel.
Thank you.
Here.
Well, thank you. I'm going to avoid the presentation myself. Okay, just to mention about my sabbatical year, University of Dundee, of Professor Alan Cuthbertson and also Professor Peter Davies, basically in the area of environmental fluid mechanics. My area of interest, just to add a couple of points about what Carlos did, is that also I work with laboratory with numerical modeling of physical processes, currents, waves, sediment transport, etc., and also lab modeling of freshwater mixing in a facility where we mix fresh and salt water, and we evaluate and we investigate how is the mixing processes. One of the interested, and also one of my area of interest, is to develop low-cost and do-it-yourself oceanographic instrumentation. This kind of instrumentation is to get microcontrollers like Raspberry, Arduino, and also low-cost sensor, acoustic, optical, or pressure sensors to develop oceanographic institutions that are quite suitable for developing countries. That it's also one of my area of interest, that it's research collaboration with universities that are mainly in Mozambique and also in Senegal. However, what we're going to talk today, my talk would be related with the Ebro Delta. Ebro, it's probably the main river on the Iberian Peninsula. It occurs in a microtidal environment, so it's less than 20 centimeters, the tide, and this is going to force not only the shape, also the physical process involved in the Ebro Delta vicinity. The water depths of the Ebro Delta is between 200 and 1,000 meters cubed per second. It's a low-lying delta. You may see here how it's a lobate. And this is just a few centimeters from the above the sea. So what happens that it means that this is a hot spot in terms of coastal erosion, and it means that also it's very vulnerable area due to the climate change. It has the typical processes that occurs in this delta. It's the subsidence and the coastal erosion, and it's mainly because there is a lack of Ebro River sediment supply because upstream has been built different dams. Well, focusing on the Ebro Delta also from anthropogenic activities, it's a hot spot. There are a rice crop from the paella, from the paella, the rice crop that we cook, and it's the paella that they cook here in the Ebro Delta. But also there are aquaculture. We will see mussels, oysters, raft, and fishing, local fishing, tourism, and also it's a natural reserve as a migrating bird. There are a couple of endemic fish species. Focusing on Ebro Delta, there are 2 bays in each hemidelta. At north it's the Fanga Bay and south is Alpac Bay. That will be the focus of my talk. Well, just to mention before, in the representation of the Galloway classification of the deltas, Ebro Delta is located here. It's a wave dominated, it is not tide. The river is relatively small in comparison to other rivers. So it's the shape of the delta, it's quite influenced by the wave action. Just some pictures to realize our study site. First of all, we can find quite isolated beaches. We cannot access to that beaches because there are plenty of birds and also endemic species. The natural reserve, it combines activities or it's mixed activities with the rice crop that, as you know, it's the rice crop. It's in some of the fields has a wet and dry period. Are flamingos from the natural reserve, and it's a nice picture because here beside the natural flamingo, this structure here hang out some ropes where the oysters and the mussels grow up. Okay, so you may see that there are plenty of activities here, and you may see here that plenty of cars on the beach. That's it's another pictures that now has been some regulation to avoid this massification of these beautiful beaches. But you can see here that there is a restaurant and they built a breakwater to protect from the coastal erosion. So that gives us an idea how was the shoreline tens years ago. So now has been a retreat, a coastal retreat, and an important coastal erosion of the coastal line. What happens with these bays and why these bays are quite important and they deserve our attention? Well, this bays has, as again, all these black dots point here are aquaculture, are mussels, oysters, rafts, and also are surrounding these bays. There are the rice crops, some nice beaches. So it's a quite natural and also economic pool. In these bays, there used to be freshwater. There are freshwater ditchers that they came from the rice field, and the estuary classification of this bays, it's a salt wedge. Salt wedge, it means that we have fresh water in the upper layer and salt water in the lower layer. So it's an exchange estuary that in some events when there is a strong wind, the wind is able to erode the isopycnol and convert the estuary in a well-mixed estuary. So from a scientific point of view, we start to see that there are a lot of interesting points that will deserve our attention. Also, it's a low renovation area. Remember, there is not tide. What does it mean? That there is an increase of temperatures. In summer, it's a hot point, the increasing of the temperatures, because currently is killing the mussels raft with the economical impact on the region. Also, used to be once in a while HAPs, low level of dissolved oxygen, and also there is the supply of nutrients that is good for the fauna, for the aquaculture installations, but also the pesticides that can kill also the mussels and the oysters. Also, there is another problem. This is a speed. It's a propagation of this sandbar that at the same time it's closing the river mouth. So you may see that there are a lot of things to do. And the last point is that because the current drought in the Mediterranean or in the Catalan region, this estuary has been converted in an inverse estuary. So it means that because the evaporation and the shortage of freshwater ditches, currently there is a strong evaporation. So it means that there are more salinization, more the saline waters within the bay. They are larger than the saline water of the open ocean. So in the framework of to try to deal these problems, we launched the EcoBase project that based on the anthropic and the climate perturbation we try to provide using different tools such as numerical modeling, remote sensing, in situ data. We try to provide a natural-based solutions. We will talk later about what is the meaning of natural-based solutions, but it will be natural solutions that are far from the classical engineering projects of to build rigid extractors and are solutions sustainable with the environment. What we are going to do today, or what I try to do today, is to provide an overview of the different measuring techniques that we are developing here in the base, and also to have an overview of the different physical process in this base, in Fangar and Alfax Bay, and to try to face the future challenges of this base. Well, as I told you before, let's going to have a look about the Fangar Bay. It's an intense aquiculture, mussels and oyster raft. To have a reference, it's relatively small, 6 kilometers length, but per 2 kilometers wide width. The average water depth is 2 meters with a maximum 4 meters water depth. The mouth width is 1 kilometer. And there are two main freshwater discharges that are these red circles. How is the water circulation? Because it is not tight. The water circulation used to be driven by wind, when there is wind, obviously, and also by the gravitational circulation. It's a typical stratified flow where the freshwater flow is flowing in the opposite direction of the saline water underneath. And this is the main drivers of the water circulation. And also another funny phenomena that I will talk about later is the sage that has been observed. Well, which is the methodology that we used to use here in this kind of base. First of all, we developed in EcoBay project fundamental seasonal field campaigns to gather the different seasonal regimes. As I told you before, because the rice crops, they used to wet and dry in function of the crop developing. So that it means that also we plan a seasonal field campaign to get these different regimes in temperature and salinity. About water currents, we are using low-cost Lagrangian balls. They are drifted that we are tracking with a GPS. So we have the position. If we have the position, in each time we can get the surface velocity. And also ADCPs, that is acoustic Doppler current meter profilers, that they provide us different velocity profile at different depths. These devices that you can see here is a beam where there are mounted the different devices, and this beam is drilled onto the sea bottom with a large metal stick. Also ADB, that is for high resolution, and in parallel we did the CTD profiles. It's the conductivity, temperature, and density profiles. The conductivity, they provide us an idea, they provide us the value of the salinity. We get meteorological station and also additional water quality parameters. Oops. Okay, another tool that we use is numerical modeling. In that case, we implement different configuration of the regional ocean model system. It's typical 3D hydrostatic numerical models that work in primitive variables. We can get information about current, sea level, salinity, temperature. Also, we work with different meshes, different numerical meshes to get as much as possible resolution within the base. In that case, it's 350 meters and 70 meters. They are nested into the Copernicus oceanographic products that they provide the information at the boundaries. Also, well, it's 10 sigma vertical levels also to get information about the water column, and it's forced by ACMWF atmospheric data, and also
the first time there's a really interesting presentation related to what I did in my PhD. So it's very bad time.
local wind data.
Maybe I will find you there.
I think that somebody forgot the micro open.
Konstantinos, can you hear us?
Yes.
Can you switch off your mic, please?
Oh, sorry.
Thank you. That was weird.
No problem. And also this model, the hydrodynamic model, is coupled with a basic phytoplankton evolution model that is the NPZD to try to track the phytoplankton or the chlorophylla within the bay, because you know it's the food for the mussels and the oyster raft. Another tool that we did, in fact, is photographed for the last week. But we have done several times a dye tracer release experiment. In that case, we get a rhodamine dye. It's innocuous, so it's not harmful for the environment. And then we release this solution of the rhodamine dye, and that solution, it may be detected by low concentrations by an appropriate fluorimeter. In that case, there is a small peristaltic pump that you can see here, a peristaltic pump, so we know which is the flow that we are introducing within the bay, and in that case, it's required calibration in laboratory. Why it's useful, the dye trace? Basically, it's useful to investigate the dispersion coefficients in horizontal and also in vertical. That, as we will see later, it's linked with the nutrients and the pesticides dispersal within the bed. So we have a couple of boats with the fluorimeters that we're sampling in different positions to get how is the evolution on time. Well, to get the evolution in time, may be interested, but because the fluorimeter it's easy to see with a simple eye, also we use the autonomous aerial vehicles, drones, for a water surface tracking. In that case, the drones allow us to get the geoposition and to obtain the evolution of the surface spreading of the tracer. In that case, you can see here how we start with the temporal sequence of the experiment from 10:30 to the 4 o'clock in the afternoon, and we can see how is the evolution of the tracer. Well, the water circulation, the results that provide us, the campaigns that were carried out, provide us interesting information about how is the water circulation. Because there is no tide, the water circulation is quite tricky, because the first thing that we must to take into account is that the velocities that we recorded in the inner bay, it's very small. We are thinking, we are recording, observing velocities of 10 centimeters per second, that in comparison of a tidal coastal bay, that it's much more less. What does it mean? That during the calm period, used to be a stratification. It's a two-layer follow. As I mentioned before, it's a salvage estuary that we have a saline water from outside, from offshore, and in the upper layer we have fresh water. There is an entrainment and mixing processes in the interface that generate this kind of gravitational circulation. But what happens when there is an intense wind event? Here you may see the velocities in blue and the velocities in red. It's in the direction of the entrance of the channel. So what does it mean? That when there is not wind, wind is the first time series, you may see that it's more or less a two-layer flow, as I told you before, in the opposite direction. But then in the yellow boxes, it's an intense wind event that it makes to mix all the water current. However, it happens something quite interesting. This wind event, it follows its up bay wind that we call it, or winds from the northwest. And we recorded here in the blue spot, you have to believe me, but negative values, it means that the flow is outwards of the bay. So here it happened something that we were quite surprised, that the wind direction and the water current direction apparently are not consistent, are in the opposite direction. And it's something that happens last week when we were measuring with the tracer. We also got the same results. We said, wow, this is the green arrows, it represents the currents, that it goes in the opposite direction to the northwest wind event. And we couldn't understand previously why this happens. It was well mixed, but it was against the common sense that the current is against the wind. So we did some kind of idealized numerical experiment with ROMs, that this work is published in Balcells 2020. And because, as I told you before, the hydrodynamics is quite complex because there is not a periodic phenomena like the tide. So it's quite complex, the velocities. We try to solve an idealized bay, and we develop different geometrical solutions. Basically, the solutions are divided in the bottom, in the flat bottom seed, and then we introduce here some kind of bathymetry artifact that to try to reproduce how is the real case. Here it's much more in the lateral near to the shoreline, it's shallower, and in the center of the channel is deeper. And then we change, or we introduce different wind direction and wind intensity. Wind direction following the axis of the day. Well, I show you here all the solutions, and we are not going to pay attention in all the solutions, but I would like to highlight here in the upper panel. In the upper panel, in the surface and the bottom currents, we can see here how the flow is upward to the estuary. Sorry, that the wind is upward. It's the blue arrow, 12 meters per second. And we may see how in the surface currents there is a lateral flow that goes in the direction of the wind. But the most interesting that in the bottom currents and also a little bit at surface currents, there is a returning flow that is opposing the wind directions. And finally, we can figure out how is the circulation here in this kind of bays. If it would be an homogeneous depth, it would respond the wind. This is the direction of the arrow of the wind. It would respond something like that to this circulation. But because there is an equal bathymetry, the pattern is like that. It's a lateral flow that is following it's consistent with the wind direction. But in the center of the channel, there is a return flow. Well, now that we know a little bit what happens with the water circulation, we try to link the water circulation with the CLA, with the chlorophyll. How we did that? Well, in that case, we use the model couplet, the ROMs with the NPZ, the model coupling, and also we get satellite from Sentinel-2. Sentinel-2 provides us information about the surface, the chlorophyll at surface, and we saw that when there is an intense wind, if the wind is it's a downwind, it means that the wind is on direction. It's on direction of the estuary main flow. The flow, it goes following the shoreline, and we saw that during that period of time, the results are quite consistent with the satellite in both cases, in that wind and also when there is a wind that the freshwater flow that it's providing nutrients, let's not forget that it's providing nutrients within the bay. The production, the primary production, it's mainly concentrated in the inner part of the bay. So that happens when there is an intense wind, that it causes an increasing of CLA, because there is a horizontal advection of mixing. Advection of mixing, and that's because the wind event. However, also we have seen that there are another phenomena, another effect that is still, we are trying to figure out, that there are some kind of resuspension of biomass from the bottom that incorporates at the same time nutrients in the water column. And this makes also to increase the chlorophyll in some points that are not affected by the horizontal advection from the river freshwater. Again, we saw that after a wind event, also there is this increasing of chlorophyll. And just to close my talk, because I don't want to extend a lot, I would like to talk a little bit about the natural-based solutions. The natural-based solution is a sustainable management and use of natural filters and processes to tackle environmental issues. In that case, I have mentioned before, we have two main environmental problems that let's see how we can solve. One of the problems is the poor water renovation, okay, because as I told you before, the water velocities are quite low. Generally, there is not wind, so it's a very calm bay, so it's perfect for a hub or also for low oxidation dissolved events. Also, another problem is the high temperatures that leads a high muscles mortality. So what we can do from a natural-based solution? Here we suggest two different actuations. One is to manage the freshwater ditches. What happens if we put more freshwater? If we put more freshwater, that the gravitational circulations that I mentioned before, because there is an increasing of the pressure gradient in the upper surface. At the same time, we are taking from the bottom more water from the open sea. So maybe quite interesting to think to manage the freshwater ditches. Another things that we can do is here there is a very beautiful barrier beach that it was an academic analysis, was not what happens in the reality, but something that we can do is to do a hydraulic connection with the open sea to break the barrier beach. Okay, so to do that we designed again different numerical experiments. The experiment C, it's the experiment of reference, and we will use as indicator the local flushing time. So because we have a poor water renovations, we found an indicator that it says local flushing times, that roughly it's the time that takes the water from any point within the bay to leave the domain. You may see that here in the local flushing time, the units are in days. So we did different tests, C, B1, B2, B3, R1 and R2. In these different tests, there were the experiments B1, we broke the bridge. We did a sandy bridge, a breaching of the barrier beach here with different widths. So opening of 200 meters, 500 and 800. And also in the experiment R1 and R2, we manipulate the freshwater river ditches to see if we can generate this extra pressure gradient flow due to the density gradients that allows to increase the water renovation. That's the freshwater management. It's to reproduce the salt conservation formula. It's the typical Knudsen formula in oceanography that tells us that an increase of the water river ditches will imply an increasing of the velocity on the lower layer because of salt conservation. And these are the results. If we compare the test, see that it's the control simulation, and then we subtract the different results, the B1, B2, B3, R1, and R2, and we may see that almost in all the experiments, we are able to reduce the local flushing times, because the local flushing times, the subtraction from the reference simulations, we may see that the reduction is of the order of minus 10, minus 20, and in some specific cases, minus 30. So it's worthy to mention that one of the things that we were surprised is that if we are able to manage where we put the water flow, because here in the R2, the difference between R1 and R2 is that we are including water flow in the innermost channel of the bay. If we are able to put water flow there, the reduction on local residence time is quite substantial. So currently, it's one of the solutions that the consortium of the management of the Ebro Delta is considering to improve the water renovation within the bay. What happens in terms of the water temperature? There is a threshold of the water temperature that up to 26 degrees, the mussels and the oyster die. So in that case, even that we open the barrier reefs and also to play with the fresh water, the results are not quite useful in terms of natural-based solution. Well, the last topic that I would like to talk today, it's just quite fast. It's one phenomena that probably here in the Scotland lochs are not familiar. It's that it's the sage. A sage, it's an oscillation of the water level. But how we understood or how we found that something happens in our base? Well, we got information about the ADCP at the mouth, that is the left-hand side column, and the ADCP within the day for different periods. And there were in specific periods, it means one day, 24 hours here, 24, 24, and 24. But we saw some specific periods that we saw periodic strong water velocities. These periodic strong water velocities, it's a period of 3 hours. And also we saw something similar in the ADCP that were moored within the bay, but in that case, the period it was 1 hour. The first things that we have a look, it's the wind, that it's the blue arrows here at the top of the figures, and we didn't see anything special when we compare with the other periods that are random periods that we choose, but we didn't see anything special. Also, we choose here a quite energetic wind periods, and we were quite, it was quite strange, quite weird that we saw even that here there are more wind intensity. The velocities at the bottom of the figures are lower than the velocities at the top of the figures, that the wind were weaker. So we were wondering what happens. And what happens is a sage. A sage is a standing waves that used to occur in enclosed or semi-enclosed water bodies due to an external perturbation. This external perturbation, it generates an oscillation, but then this oscillation after a couple of days used to be dissipated due to the bottom friction, but during a specific period of time, this can generate strong water velocities. And these sages used to generate 2 different special hot spots, the node and the antinode. And the node is related with the maximum velocities, that it's here. You may see this is the water level in black, and in blue and red are the water velocities. And the node is the minimum water level oscillation, that is my finger. And in the antinode, that it's the minimum velocities, but maximum amplitude in the sea level. Okay, this is the sage that not always happens, or not always it's important on the water currents, but there are specific periods that the water currents may reach 60 centimeters per second. That is a lot when the typical velocities are below 10 centimeters per second. So we were quite lucky to capture these events some years ago. Also, we could reproduce the SEISE using the numerical modeling, and also we identify not only one SEISE, but one of the things that we were to try to figure out, because these oscillations, we could identify the specific period of the oscillations. That is the period of the oscillation that was related in the left-hand side, that it was the 3 of August of 2017, I think it was 1 hour, and the 30 of August of 2013, it was 3 hours. We tried to figure out why these periods. Well, these periods are provided by the median formula, that is a fundamental period of oscillation of a water body. If we compute using the length of the estuary and also the average water depth, we get a values similar to 3 hours, that is the fundamental period of oscillation. However, because the median formula, also there are the secondary, the third and the fourth order oscillation, that in the case of alpha X Bay, the most important is the fundamental, obviously, and also the second period of oscillation, that in that case it was 1 hour, which is the difference of the first or the fundamental period of oscillation, that the antinode, the fundamental period, is located in the inner part of the bay, and the node is located here in the mouth, and the secondary period of oscillation, we have two nodes that it's where the also where the ABCP were located. Okay, that the nodes and the antinodes provide us information about when the maximum velocities occurs, and that's obviously it's related with the main period of analysis. If we do a spectral analysis of the sea level, we also can see how the main energy is concentrated. There are some diurnal and semi-diurnal peaks, but also in 1 and 3 hours period. Well, just some conclusions. The Ebro Delta Basin requires a multidisciplinary analysis for a proper management. The processes that happen there are quite complex, and some of them are highly linked. It's the case of the chlorophylla, the link about the water current, etc. There are multiple physical processes: water circulation, erosion of the pinoclines, SEISE, resuspension of fine sediment from the bottom, that also we have investigated. The natural-based solutions may be a proper alternative. We are trying to dealing with the union of the and also the union of the rice fields and also the hydrographic responsibles from the catchment area to try to provide an alternative or try to provide a solutions and the possibility to manage the water flow, because we know that if we are able to put the water flow in a specific area, we can generate much more water flushing, and also the methodology required a combined use of the remote sensing, including satellite data and also drones, in situ data, numerical modeling. I didn't talk anything about the physical modeling, that the experiments that I am doing in the University of Dundee, which I am playing with the effect of the raft, of the mussel raft in the mixing. And the future works, well, includes NP-zeta-V realistic simulation to see how is the effect of the resuspension effects on the primary production, the salinization, what is going to happen, because when there is a lot of evaporation, the salinity is higher in the inner bay in comparison to the open sea. That in that case, we expect an inversion of the exchange flow. Turbulence characterization in the pycnocline, and hopefully in the last field campaigns, we get high resolution water velocity that probably will help us to understand what happens in a micro scale of the flow. And then here I leave you several references that we have developed in the last years in this base, in Fanga and Alphax Bay. And well, it's obviously, I have done this alone. There are plenty of contributions, and many of these contributions appear in this photo that we got several months ago in Fanga Bay. And thank you so much.
Thank you very much, Manel. It's really interesting. So let's have a couple of questions. So I'm just gonna see if there are questions online. Any questions from the room? I'll start, because it's always the chair or the person responsible asking the first question. You talked about nature-based solutions, and you're talking about the option of freshwater inputs versus a breach.
Hydraulic connection.
Yeah.
Bar breaching.
Do you think, given that the Ebro Delta is in the area that has limited freshwater resources, that it's potentially more likely that, in terms of long-term sustainability, a breach would be more effective or more sustainable than trying to increase the freshwater input, or not?
There is a thing that it's playing in the side of the water quality, that due to probably the climate change and the last storms, the bar breaching is much more frequent. And currently there are mechanical means to repair the beach, but this is not sustainable because there are putting not thousands of 10 cranes dredging and moving the sand in the bar breach. I think that in the future won't be sustainable to maintain well, I said that, but probably if I would be in front of the local authorities, I would change my mind. But I think that the bar would be difficult to maintain the beach bar, and the breaching will be natural.
Okay.
I think so. Yeah. In 10 years, probably we will know.
Yeah. But I'm guessing with sea level rise as well within the
Yeah, it's playing. Yeah,
increasing the water level.
It's the sea level, but also because the Ebro Delta currently it's carrying a small portion of sediment that carried in the past, because the construction of there are a lot of 40 or 50 dams upstream. So the sediment load that it's carrying the river, it's very small in comparison to the past. So the only solution is coastline retreat.
Yeah.
It's interesting, Manel, very interesting talk. I'm interested in the delta itself and how stable it is and how long do you think it took to form? It's interesting that it's at sea level now. Do you think is it a purely Holocene feature? Are we talking thousands of years for the delta to build out, or did you think it may have started during the Pleistocene? Or?
Well, I am not a geologist, okay, that is the first point. But I have read that the delta also was created because the big deforestation that occurs during the Roman Empire. So this delta is relatively new.
Okay.
And then in the 1960s, after the Second World War or the Spanish Civil War, there were a huge economical development, and the politics of that period is to develop big dams for electrical power system. So it means that if the delta, let's say that has 1 or 2,000 years, has been growing continuous supplying of sands in 1,900, but the last 100 years, this sediment supply has been cut.
Okay.
So what is going to happen, and this is linked with the subsidence, that it's just 1 millimeters per 10 years. It's a small subsidence, but maybe relevant. Also, we have to add the increasing of the sea level height. So that converts this delta a hot spot of the climate change, and probably we are going to see here what is going to happen in the rest of Mediterranean areas in the next 50, 60 years old. What is going to happen in the next 20 years? it is, or I think that probably will be something similar that is going to happen in the next 100 years in many places of the world, because it's a hot spot. It's very vulnerable.
I guess a follow-on is, do you think the tidal range has stayed the same throughout the last 2000 or older?
Yeah, well, all the information that we have is that the hydrodynamic, the wind and the wave conditions has not changed a lot in the last hundreds of years. But in the future, they are changing. For instance, we have seen, it's not the first time that there were first bar breaching, as I told to Carlos, but we have had 4 bar breaching in the last 10 years. And in the last 60 years, the bar breaching was not weird, but was not as much common as it is currently. So everything is changing, and I think that probably changing faster than as we think. Yeah. Because the destruction of the recent storms in the bar breaching, and also the temperatures, we have registers of the temperatures of the last 30, 40 years, and the last summer we did a record of temperature in Earth Bay. In fact, another thing is that the mussels activity and the oyster activity within the bay won't be possible anymore in the, let's say, 5-10 years, because it's too much temperature.
Okay. Can I just, speaking on sea level, water level, so because it's so shallow on most of it, I would imagine that increasing half a meter with sea level rise.
Half a meter destroy half of the delta will be destroyed. Yeah.
Okay, because I was thinking the other way is that it will increase
level.
Circulation, so it's going to increase tidal tourism, so
No.
you'll have more circulation of water, but then...
I recommend you, if you are interested on the climate change impact, I recommend you to visit the Ebro Delta, because you will see that the beach, there is not a berm, it's not a natural dune that protects the delta. The rice fields are perhaps 20 centimeters from the medium sea level. When there is a storm surge, there is a pump that they must to subtract the water from the rice fields to the open sea to avoid a salinization of the fields that can kill the rice. So I think that it's a good example, because we have to rethink the human activity there, because I think that there are activities that cannot be taken in the future in the Ebro Delta. The rice, mussels. Also, we are losing a couple of lagoons that used to be very important for the migrating birds, and these lagoons will be destroyed in the next years, I think. Not to be pessimist, I don't want to be pessimist, but to be realistic, it's one of the most, we can see the most straightforward impacts of the climate change in the Ebro Delta. So I recommend you to visit before disappear.
Yeah. So book your flights.
Book your flights tomorrow.
Okay. One last chance for an online question or a room question. No? Okay. So one last round of applause to Manuel. Thank you very much. So, thank you very much.
The rice and the mussels is making me hungry. So.
Yeah. But I was talking